Abhishek. I worked on the Druid Delta Lake extensions. Yep.
My name is Will. I'm the product manager for Druid Engine. Before this, I was the PM for Hive and HBase and Druid and Phoenix. And then before that, I was the PM, the first PM for Datadog. So you might have used a few things that me and my team has built in the past.
I'm Gian Merlino. I have not worked on as many things as Will. I've been working on Druid for 10 years. I'm the PMC chair of Druid.
Hi, I'm Atul Mohan, and I've been working with Druid for a while now. Now I'm mostly focused on the Iceberg integration with Druid.
All right, so we got a lot of brain power up here. So let's just kick off with some questions we have started. So to kick it off, we're going to have a question here for Atul. Since Druid maintains its own schema, how can it be integrated with a catalog used in a Lakehouse?
So I think this was mentioned in the talk again. So there are a lot of metadata management platforms out there like DataHub, which is very agnostic of what database you use. So what it can do is it can ingest the schema from the databases and make it available as part of a shared unified catalog. So what you can do with that is if you have Iceberg and if you have Druid, both of the schema for these data sources can be ingested into DataHub, and that can be made available for the query engines to process. So yeah, the point is to use a platform that has integrations with Druid and other data sources.
Cool. And as I should have mentioned this earlier, but these questions sometimes are targeted a certain person, but any of you, if you have anything to add, feel free, since this is a panel. But we'll go on for the next question now. So this one was directed to Gian. Earlier today, we heard about this new profile that Druid has to support data warehouses and data lake use cases. How does this new engine make Druid a better tool in the data analytics space?
That's a good question. So I think with when you're designing a data system, you're designing how you're going to do your data architecture. Interoperability is important. So we talked about Iceberg and we've heard about Delta Lake. There's also a multitude of query engines out there. And interoperability is important, but it's also, I think a lot of people like to not have too many tools. So we try to do two things at the same time. We try to balance this as we build our roadmap. We try to do some work that helps with interoperability with other systems judiciously. So a few years ago, there was a huge push to have really tight integration with streaming systems like Kafka and Kinesis. As Eric was saying earlier in his keynote, that's relatively mature now. And so a lot of the focus now is on integration with lakehouses. And on the query engine side, I think a lot of the work we're doing on the query engine side is making it so we can handle more workloads in Druid than just the classic real-time analytics workloads. Because it's a super, super common pattern to say, I'm going to have some tables that are managed by Druid. That tends to be a lot of your real-time tables that power your real-time apps. I'm going to have some tables that I'm managing as Iceberg tables or Delta tables. And I'm going to query the Druid tables with Druid. I'm going to query the Iceberg tables with Trino or Spark, SQL, something like that. And as to that side of things, we want to make it more possible to query more tables wherever they are with Druid. And using Druid as a query engine that is sort of a query engine that is the ideal query engine for event data, which means, to me, having good integration with external tables like Iceberg and Delta Lake, and also having a really, really good internal table format that supports real-time data and is going to be generally higher performance than using the external tables, because when we're able to vertically integrate the query engine with the storage format and with the storage layer, you can unlock performance that's not really possible when you're taking this query engine and this data format and like this lake format.
Cool. All right.
Yeah, and then to sort of like add to that, one of the factors I keep considering when designing data systems or data platforms for various folks is around sort of the trade-off between performance and cost. Usually, when you run queries against data that's already landing or ingested into Druid, the per query cost is very, very low, right? We're talking about probably like 1/100th of a cost if you were to run that query against a data lake directly, right? If you try to run one Spark query against some Parquet files, you're paying a lot more on like a per query basis. So the common pattern I've seen what people do is they will have a lot of data living in Iceberg or Delta Lake. The data scientists or the data engineers will run a lot of the prototyping, a lot of ad hoc queries and analysis on the lake using the more expensive per query engine, because you're not repeating query pattern, right? You're mostly running this, one query shape maybe 5 or 10 times. And once those customers or users are satisfied with the model, they will say, okay, let's materialize this into Druid for serving, right? And then you're now ingesting from Delta Lake or Iceberg into Druid, and you're serving at a much, much, much lower cost on a per query basis. So that is sort of like how I've seen how the new query engine that we're able to provide user the ability to do ad hoc queries, as well as sort of like serving in the same engine, so you get like consistency from experiences.
Yeah, cost is actually really interesting. Like, is a design like Druid's today, where you have the data preloaded on the servers and it's already there, it's warmed up in memory. Like, is that lower cost, or is it lower cost to have data in a lake and to query it with something like Trino? And I think the answer is it depends. Some people say, I love Druid because I can serve my app at like the lowest cost because the data's all there, it's super efficient. And some people say, I don't like Druid because it's too expensive. And how can both things be true? And it's true because I think when you have low concurrency and not a lot of repeated queries, then the lowest cost comes from spinning up infrastructure in Kubernetes, on demand to run a query and then tearing it down. So kind of like very short-lived compute is where low cost comes from. And when you have a app that is querying the same data over and over and over and over and over again in sort of similar patterns from query to query, but different filters, different groupings, then Druid's techniques of having the data preloaded with indexes that are optimized for those repeated queries is going to be lower cost. So it kind of depends, and a lot of the vision that we have for Druid on the query engine side is like supporting both of these cost models in one system, because again, it kind of sucks to have like a million different query engines, I think. I think there are going to be a lot of different ways to store data. I mean, it makes sense to store data in Kafka. It makes sense to store data in Druid. It makes sense to store data in Lakehouses. I think that makes a lot of sense, but it'd be great if you didn't also need like a dozen different query engines.
All right. This next question kind of sounds like it was already answered, but we'll ask it anyways and use it maybe to sum up, or if anyone else wants to join in. Bring it up on the screen here. Okay, there we go. So, given there are so many data warehouses and data lake solutions, where is Druid's place in the broader data lakehouse ecosystem? Anybody can take this one as a jump ball.
So, I mean, as I think Gian mostly covered.
Yeah, so I kind of thought too.
Yeah, so I think from my perspective, it fits into that fast querying layer at this point from whatever capabilities Druid currently provides in a lakehouse. So with the existing query engines, what you have in terms of Trino or Spark SQL, it does not, there is still a gap to provide sub-second query latencies to cater to dashboards that require high concurrent, low latency querying. So that is the void that Druid fills currently in the Lakehouse, and it has been very popular with the people who use Druid in that capacity. So that's something I want to do.
Cool.
So a related question I have for you who's actually using this stuff in real life. There's two integrations you can imagine between Druid and Lakehouse ecosystem. You can imagine a integration where Druid reads from Iceberg, reads from Delta, for both ingesting data and for querying data live. You can also imagine something the other way around, where like Druid exposes its own data in a format that is legible to other query engines. And that's something that has seen less work in the community so far. I'm wondering if that area is something that would be interesting to you and your team.
I think it would be, especially right now Druid is doing all the heavy lifting as if the integration with the other external formats, but having a certain standardized format that other query engines can leverage can be a game changer, is what I think. But yeah, we are not there yet, as you know. Yeah.
Yeah, I think we've been focused on the one direction first, but the other one is also interesting. Just hasn't seen as much work.
Yeah, I think that would drive more adoption, especially with folks who don't really know how to set up Druid, they don't use Druid, but you have a standardized format that you just have the ingestion layer, ingest the data into the Druid format, and you have other query engines use the standardized format to query the data. I think it would be, it would really increase the adoption in a Lakehouse.
Yeah, I think a few of us tried to take a stab at exporting Druid segment files into open table format, and we ran into a few headwinds with that, but I think it'll be a cool idea that other systems can just integrate into and leverage that. Yeah.
What would you run into, out of curiosity?
It was just mostly a hackathon project, so time crunch was a problem, and yeah, I think we just need to invest more time into getting unblocked with connectivity with Spark, and I think there was some nuances, data type compatibilities and things like that needed to be fleshed out.
I've always wondered if we were going to expose Druid tables in that way. Like, would we expose Druid segment format in a way those tools would find legible, or would we actually have Druid manage a table that's not in its own format with all the indexes, but is something like Parquet that's more standard, even if it doesn't have all the indexes that we like to have? I'm wondering which direction you were thinking about going.
I don't know yet. Well,
yeah, fair enough.
All right, our next question, this one's aimed at Gian. All right, earlier we heard about some of the challenges brought about by deletes. How does Druid handle this now, and how can that be improved? And anybody can follow up too. But.
Yeah, I mean, I would imagine that a major way we handle it now is by re-ingesting, from scratch a whole partition. That's typically how we handle deletes in, even if it's not a Lakehouse. Is that how you're generally handling deletes with your Iceberg integration? Mm-hmm. Yeah, so if you have a delete show up, or if you have incremental insert show up, generally you'd be able to add the incremental file and load that. But if you have an incremental delete show up, then you would need to reload the time chunk where the delete showed up. A lot of people have a lot of history, and deletes show up for recent data, so you're reloading the recent time chunks for a little while until you stop seeing deletes. Or I guess in the extreme case, you might need to reload the entire table if you could get deletes for any row.
So I think one interesting idea you mentioned yesterday was having some kind of a tombstoning approach within the segment, where if you have a delete row that comes in, you tombstone that within the segment, and which can be later removed using compaction or something. So that is just an idea that kind of sparked a bunch of different ideas for me. So I think in the future that could be something useful. What do you think?
Yeah, I think in the Delta talk there was this concept of a deletion vector, which I think is a similar concept. You imagine I think a similar deletion vector concept might work inside Druid itself. You could imagine one being attached to every segment. And if it was a bitmap, then the historicals would be able to use that to filter out rows along with all the other indexes that we have. So I think that could totally be a path forward to being able to handle them with a little more efficiency.
Yeah, I think like at a broader level, when people come to me to say, hey, can you support deletes? I always ask, like, why do you want to delete your data? Like, for what purposes? Depending on your purpose and scenarios, there's different ways of doing it. For example, if you're doing GDPR compliance, if it takes like a few hours or a day to delete the data, you're probably fine. Like, you're probably in good shape. But if you're like, I'm deleting like a Arenas transaction or something, I need to like reverse back all the transaction, then you probably need to do it at much lower latency, at much higher consistency, right? And then there's different techniques to do it. One sort of like interesting case is Twitch, which is a Druid user. The way that they handle data deletes is actually not deletion. The sensitive fields for the user are encrypted with the encryption key based on user ID, and then this is kept in a dimension table. Every single time you query it, you use the decryption key to decrypt the data. And then if you want to delete the user's data, they basically zero out the decryption key instantaneously, right? And then basically all the records are like deleted.
Lock it up and throw away the key?
Yeah, exactly.
Yeah, that's interesting. I was mentioning about how in Druid right now, if you get deletes, you need to reload that time chunk or reload that table. The dirty secret, of course, of all analytical systems is, at the end of the day, like every analytical system, even if it has a nice facade for deletes or for updates, like has to rewrite the table at some point, because you have a compaction process where you go through and rewrite things to rebuild your immutable data files. And so, to me, the question about supporting deletes or updates in like a nicer way is, eventually the data has to be rewritten anyway, so that's still going to happen. It's mostly about putting like a nicer user experience on it, and also about reducing the latency, because perhaps you have a thing where if you update these deletion vectors, then a delete could be legible to the system within seconds, and then there's still going to be a background job to rewrite everything, but it improves the latency of the delete operation and the user experience of it.
Cool. All right, the next one's a good one here. Will Dart support reading directly from the data lake without converting into segment files?
Funny story. So it's experimental in Druid 31, which I think is out today. That was our goal. And the first experimental version of it almost supported this, but there was a couple bugs with it, so we switched it off. But it's a few bug fixes away from being supported.
Cool.
I just had a question regarding that. So would it work since the data has to be pulled in? The data still has to be pulled in from the deep storage or wherever it is, right? So there's still going to be a latency associated with that, correct? So do you think Dart can bridge that gap at some point? Or is that latency always going to be there?
I think that we can bridge the gap. That wouldn't be Dart's job. In my closing keynote, I'm going to be talking about a little more technical. So the opening keynotes were very kind of high-level stuff, and the closing one is going to be a bit more technical and sort of tie everything together. I'll be talking about Dart and our virtual storage layer we have planned for next year and how those fit together. But preview is that would be the virtual storage layer's job. So the idea is right now we have a storage layer that for Druid data, everything is stored on cloud storage. All historical data is stored on cloud storage. We preload stuff from cloud storage. So the Druid server is based on these load rules that if you use Druid, you're familiar with those. And then anything that's been preloaded can be queried. And then for external tables, they're also stored in object storage, and we pull them on demand and then throw them away when the query is done. So that's how the storage layer works today. And the evolution of the storage layer is a unified storage layer that has both the pulling from deep storage and the caching abilities for both Druid data and for external data. So putting them all through that system such that whether we're loading from Druid or whether we're loading from an iceberg table, we are still pulling stuff on demand if it's not already local, which for the iceberg table it probably wouldn't be. But we are then caching it, and then if more queries come in for that file in the next, as long as it's there, then we'll preferentially send queries to that server. So I think that the combination of Dart and virtual storage together make this possible.
Sounds very exciting.
All right, here we go. Is another good one. This one came in actually 2 different versions, but I'm going to choose this one as the representative. What are your thoughts on making the Druid segment file an open version spec like Parquet and Orc so that compute engines can operate on segment files in deep storage directly?
Well, it's open source, so it's an open spec.
Right.
The spec is there in the source code, and it's in a nice little Java doc comment. You can read it. I think the issue is not that it's not open. The issue is that it takes a lot of work on behalf of the community to make something a standard that is actually, to make something a standard as opposed to being something that's open. So, I don't think Parquet is an official, IEEE standard or whatever, but it's a de facto standard. And to make something a de facto standard, you got to do a lot of talks about it, you got to push it, you got to work with other communities. And I don't think at this point, Parquet, as far as I'm concerned, it says Parquet and Orc here, but I think Orc is not as popular as Parquet these days. I think Parquet has essentially won the battle for being the open standard for analytics. And I think that we don't use Parquet internally, nor do we have plans to, because we don't think that Parquet is the right format for what we do for real-time analytics. Right. There's aspects to how Parquet is designed that make it more ideal for queries that are very scan-oriented, and I think that's those sorts of queries, and less ideal for queries where you want to have a lot of indexing and random access. But that being said, I think it's interesting to think about both of those directions. It's interesting to think about, how do we make the data in Druid more legible to other systems,
right.
And also how do we make data that's stored in Parquet more legible to the Druid query engine. And right now, that second one is the focus. That's a lot of the active work is on that area, although the first one is also interesting.
Yeah, sort of to add to that a little bit. Usually the file format that come with the engine works the best. It's sort of, I don't know how many people have ever swept out your stereo out of your car, right? Sort of the original factory one usually is the one that works the best. If you look at Hive and the underlying file format, org, the org file is laid out on a disk in a way that it basically maps to the in-memory structure of the Hive engine. So whenever the org file gets loaded into the in-memory engine, when Hive starts executing on it, it's very fast because it can make some certain assumptions about the memory layouts.
Yeah, Druid's the exact same way.
Yeah, Druid is exactly the same way. Parquet is very, very tightly coupled with Spark in a very similar fashion, right? So if you want to get the most out of an engine, you should sort of use the engine native file. Storage cost is like pretty cheap, usually, right? So duplicating data is actually not a huge concern usually. It's usually worth it to transcode into a format that's compatible with your engine.
From a design point of view, I think that the strategy that we're going with Apache Druid is similar to what you see from, I think, the biggest, most popular proprietary cloud products like Snowflake and BigQuery. They both have a in-house format that in their cases is not open and not documented, and you don't even get to see the files because they're cloud services. But they're there, and they're in their own proprietary format. And they also support external tables, and so you can tell Snowflake to have an external connection to a Parquet table or an Iceberg table. It will cache the files locally. It will query them. They tell you in the documentation this will not be as fast as a native Snowflake table, but you have the advantage of having like 0 ETL. You don't have to copy it into a Snowflake table. And I think the way I think that strategy is what makes sense for a project like Apache Druid that has like a very strong vertical integration, but also wants to play nice with ecosystems. So we're taking cues from that strategy.
Cool. All right. Let's go to our next one here. This was kind of related to what you just mentioned about their second option there. So now that you can query from deep storage, what is stopping Druid from presenting itself as the data lake?
I guess you can already do this today. Since Druid 20, we introduced this in Druid 24, the asynchronous query engine, and then as of Druid 29, it's GA basically, and people are using it live in production today. If you're on Kubernetes, it can even autoscale by using Kubernetes native runners. You can query a segment that lives in deep storage without ever loading them onto historicals today. So you can kind of do this today already. And you can also query actually out of Delta Lake and Iceberg without ingesting data as well, but very, very slowly.
I mean, at implied, Druid is our data lake, obviously. So I think it can be your data lake if you want it to be. I think as to why not every organization makes that decision. I would think that from what I've seen, there's a couple of factors. I think one factor is up until recently with Dart, the support for doing queries with large joins and window functions and large subqueries very rapidly or without running out of resources. So that's something that now is, I think, going to be not a blocker at all, but it has been in the past. And I think the other one is I think a data lake to me is something that there does need to be some degree of interoperability with other tools that read the same data. So let's say that you have data that's managed in Druid as a Druid table, and you're doing all your SQL through Druid. SQL is not everything. You still have the need to maybe do train ML models or whatever. So there's still going to be other tools that you need to run the same data. I think that for people that have a wide variety of tools they want to run on data, they may choose to use an open Lakehouse format like Iceberg or like Delta. And then for that, I think we want Druid to be the primary SQL query tool for that. And for that to make sense, we need to have very good external table support. And so that's why we're now starting to think about improving our external table support with things like caching of Parquet files and whatnot.
All right. Anybody else want to add anything to that? No? All right. Well, we have one more here. Let's see. This one's aimed for Atul. What motivated you to build the Apache Druid Iceberg integration?
So it was mostly to simplify the ingestion workflows. So Druid reading Iceberg data is not a new use case. We've seen that happen over the past couple of years. But the pain point has always been to have like an intermediate compute engine like Spark to do the heavy lifting for Druid. So let's say if a Spark job that is supposed to read the Iceberg data, it fails. Now you have to go back and rerun the DAG, and there's lots of downstream implications for that. So the primary motivation, as I said, is just to clarify or simplify the whole ingestion process. Why not have it's the same process of what Spark does, where it reads from the latest snapshot and identifies the data files from it. So we just thought, why not let's have Druid do the same thing. The only challenge we had to pass is to understand how the input source nesting would work, because Iceberg by itself is not a traditional file format like what we have in Druid, like Parquet or Orc. It's like a pseudo format for Druid, so we had to find a way to make it work with a nested input source where the Iceberg input source runs first, and that would identify the base input source, which would be Parquet or Orc, and use that to ingest the data into Druid. But once we figured that piece out, yeah, the rest was pretty straightforward, and it helped out a lot of people.
Cool. All right. We got our last question here now. For data lake use cases, will Druid's query engine ever get comparable optimizer investment comparable to Trino? Them sounds like fighting words.
I guess I'll take that. We have, so in Druid, our optimizer is Apache Calcite, which is a optimizer that is used by a ton of open source projects and has a lot of investment into its optimizer. So I would say the optimizer that we're using has already got investment similar to Trino's. We just are not making use of it. And we're not making use of it because our query engine historically has not benefited from things like join reordering and moving things around throughout the query. It has historically not benefited from that because of the structure of the query engine and how we run queries. I think with doing more queries with query tasks and with Dart, there is more benefit to be had from actually leveraging the optimizer built into Calcite, and we're going to be doing more of that. But in general, we love Apache Calcite, and we totally intend to leverage that community's use that optimizer rather than building our own.
Sounds good. All right. Well, thank you all for the questions, and big thanks to our panel for the wonderful answers. Give a hand for them.